Hey there, this is Amir Khan from IQ Academy Coaching Center, and today's topic is Angular Projectile Motion. Before we begin Angular Projectile Motion, don't forget to subscribe to our channel and to press the bell icon so that you may be notified for all our future updates. Angular Projectile Motion. We all have thrown a ball up and it always comes back down. If you throw something at an angle with the horizontal, it always comes back to ground. The path it is taking is angular projectile path, and the motion of such a particle is known as angular projectile motion. So when an object is projected at an initial angle with the horizontal, the motion of the object is called angular projectile motion. Trajectory of angular projectile motion. Consider an object being thrown obliquely with velocity u at an angle theta with the horizontal. The horizontal component of its velocity becomes u cos theta and the vertical component becomes u sin theta. Now you have to be mindful that the horizontal component of velocity will not change, just like the previous case. So u cos theta is constant. But the vertical component of velocity u sin theta will change because gravity is acting downwards. Now the object travels some distance and from O and then comes to point B. So distance from O to B is the range, and at point A it is at the maximum height. We have to find the path of the projectile, that is the path it takes from the point it leaves the ground and the point it comes to the ground. To find the trajectory, we find the displacement covered in the x-axis and the displacement covered in the y-axis. The displacement covered in the x-axis is given by x equals u cos theta into t. So from here you get t equals x by u cos theta. The displacement in the y-axis is given by s equals ut plus half gt square. Putting the values there, we get y equals u sin theta x by u cos theta plus half g x by u cos theta whole square, because here u is the vertical component of velocity, which is u sin theta. Here we get y equals x tan theta plus g upon 2u square cos square theta into x square. It can be written as y equals px plus qx square. Since tan theta and g upon 2u square cos square theta are constant, we can replace them with new constants p and q. This becomes an equation of a parabola. Thus, the trajectory of angular projectile motion is parabola. Maximum height. At maximum height, the vertical component of velocity is 0. So using our formula v square minus u square equals 2gh, we get 0 minus u square sin square theta equals minus 2g into hm, where hm is the maximum height. Or we have hm equals u square sin square theta upon 2g. Time of maximum height. At maximum height, the vertical component of velocity is 0. So, using formula v equals u plus gt, we have 0 equals u sin theta minus g tm, where tm is the time of maximum height. Or we have gtm equals u sin theta, or tm equals u sin theta by g. Time of flight. The time of flight is the time taken by the projectile to reach to the ground after being projected at some angle from some point. So, for time of flight, we know that the displacement in the y-axis is always 0. So using s equals ut plus half gt square, we have 0 equals u sin theta into time of flight minus half g into time of flight's whole square, or it becomes half g into time of flight's whole square equals to u sin theta into time of flight. Time of flight cancels out at one end and we get time of flight equals 2 u sin theta by g. Horizontal range. For horizontal range, we just multiply the horizontal component of velocity u cos theta with the time of flight. So using r equals horizontal component of velocity into time of flight, we have r equals u cos theta into 2u sin theta by g, or we have r equals 2u square sin theta cos theta by g. We know that 2 sin theta cos theta equals to sin 2 theta. From here we get r equals u square sin 2 theta upon g. Velocity at any instant. To find the velocity at any instant, we find the velocity in x direction, velocity in y direction, and the resultant of them give the velocity at that instant. So we know that the horizontal component of velocity is given by Vx equals u cos theta, and the vertical component of velocity is given by Vy equals u sin theta minus gt. So the velocity of the projectile at that any instant is given by v equals under root vx square plus vy square. Putting the values we get v equals under root u square cos square theta plus u sin theta minus gt's whole square. Or you can say that v equals to u square cos square theta plus u square sin square theta plus g square t square minus 2u gt sin theta. Taking out common u square, we get cos square theta plus sin square theta plus g square t square minus 2u gt sin theta. Sin square theta plus cos square theta is equal to 1. So we have v equals under root u square plus g square t square minus 2u gt sin theta. Angle of projectile at any instant. If beta is the angle which the velocity vector makes with the horizontal, then tan beta equals velocity component in y-axis divided by velocity component in x-axis, or tan beta equals u sin theta minus gt upon u cos theta, or we can say that beta equals tan inverse u sin theta minus gt upon u cos theta, or beta equals tan inverse tan theta minus gt upon u cos theta. Don't forget to subscribe to our channel and to press the bell icon so that you are notified for all our future updates. Thank you.